Today we will be seeing types of machine learning, types of machine learning, and the total syllabus which we will cover in this entire course. So as we know, machine learning is broadly classified into three types, which is supervised, unsupervised, and reinforcement learning. So now let's see what is supervised learning. Supervised machine learning. Now let's assume we are at a school and this teacher wants to teach this kid the table of 9. So she will start by telling 9 ones are 9, 9 twos are 18, 9 threes are 27, and this goes on. So here the teacher is giving the child the input, which is 9 times 1, and also the output. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Here we are getting the input and also the output. All we need to do is just memorize these things up. We have to do is memorize. If we talk in terms of higher mathematics, then can we tell that there is a input x and we have to find an output y? Now, what does this terminology mean in math? For an input x, you get an output y based on some process. Yes, we call it a function. So we have a f of x where x is the input and there's a mathematical function which computes the value for respective x and gives us the output. In supervised machine learning, we give the input x and we also give the output y. Remember, here giving the output is important. Now you may ask, why do we have to find this function? What's the use? Now, imagine you have a automobile shop. You have an automobile shop and you get cars to sell for second hand. You have to predict the perfect price to pay to the customer who is paying you, and also you have to predict the perfect price for a new customer who is buying that car from you. So what do you see? You see the car's years, how many years it has been working, the total mileage it can give currently, how many kilometers it has run, how many seaters it has, is it an EV, SUV, or something. So here every feature, let us call this as x1, mileage as x2, kilometer as x3, seater as x4, and this, and we have multiple till xn. Now we have to find a right, sorry. Now we have to find a function f of x1 comma x2 comma x3 dot 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 till xn to predict the output y. Now once you get this function, for every new car that you can just give the input as x1 to xn and you'll get the best price as y. So for every new x, we have to find out a output y. To find this output y, we need the function f of x. Now, let's see the total scope of supervised what we will be studying. Supervised learning. Now, first off, we will start with the basic linear regression. We'll talk about this in detail in future videos. Then we'll go to logistic regression. Then we will go to nearest neighbor. Disclaimer, if you have already studied machine learning, here I am not classifying them as a regression and classification based algorithms. I'm just giving all the algorithms which are present in supervised learning. Nearest neighbor. Fourth one is Bayesian learning. Fifth one is decision tree. Sixth one is support vector machine or SVM. The last one is multi-layer perceptron. In a more trendy way, we call this as neural network. One more disclaimer. Here there is no code at all, only pure mathematics. Now let's go to unsupervised learning. This kid is given a jigsaw puzzle. They are totally scrambled and he needs to find the correct placement position to put these pictures so that he finally completes this puzzle. Here we don't give this kid an input x or an output y, but we just tell him to find out what is present there. So, connecting this to our computer science, assume you have the Amazon data again. Now, when we try to plot this data on a graph, let the x-axis be price of product and y-axis be number of items. Now when we plot this, we might see there are few customers in this region, there are few here, there are few here, there are few here. So what can we observe here? Here are few customers who like to pay very high for products and also buy a lot of products, because here the y is increasing and here x is increasing. Here price is increasing, here number of items are increasing. These are few customers who like to buy many high price products. So they must be really wealthy. And the company, by analyzing this, tries to sell them more high price products without giving any discount. But when it comes to this case, these are less number of customers, but still buy high price products, but in very less number. So what can we see or infer about this? These are the customers who rarely or very occasionally buy high price product. Like maybe when they get a bonus in their office, maybe they want to buy a TV or a fridge of high quality. So what the company does should do? It might give them more discounts on high price product, or give offers like buy one get one. No, they won't give buy one get one free. Maybe give in buy a product in EMI. Mostly iPhone users who buy it on EMI in our country. Is that true? And what can we see here? These are the customers who buy large number of products which have very low price. And here these are might be the very new customers who pay very less or buy very less priced products and also in very less amount. So these might be newbies and still they might have doubt on Amazon or online buying. So here what can we observe? We are not giving any X, we are not predicting any Y. We just have the data and we want to find out the hidden intricacies in the data. This is known as unsupervised learning. Now, let's see the syllabus of unsupervised learning. First, we will go with LDA, which is linear discriminant analysis. Most of you who have previously studied ML might be knowing about a concept called PCA, used for feature extraction. This LDA is a precursor to it, and it was inspired by LDA. In many of the online courses, we usually don't see LDA being taught, but LDA is equally as important to understand the concept of PCA. Then after LDA, we'll go to PCA, which is Principal Component Analysis. Some of you might wonder, aren't these feature extraction techniques? But actually, these come under unsupervised machine learning, and also we use them for feature extraction. Then last one is clustering. Right. Now the final, the big giant, reinforcement learning. Now here, as you can see, there is no X, there is no predicting Y. There is no data to find the hidden intricacies. Here we just want this robot to do trial and error on this game, and through repetition it should find out how to play this game and become a master at it. It is like teaching a baby toddler to walk. We exactly don't hold his legs and put it and tell him walk like this. He just learns it by falling over and over again, finding the right balance for his body and maintaining his legs and his body in such a posture that he is able to walk. This is known as reinforcement learning. And if you call or tell about syllabus, comparatively reinforcement learning is somewhat difficult than supervised or unsupervised. So we will see this in future. Just covering these will take hell lot of time, you see. So that's it for this video, and thank you.